talk about horizontal asymptotes today, which is the same thing as the limit at infinity. So, horizontal asymptotes. Horizontal asymptotes are what happens when the x values get very, very big, go all the way to the right, or very, very small, and go all the way to the left. So horizontal asymptotes are the limits at positive and negative infinity. There could be none. So an example of none, no HA, would be something like that. There's nothing that levels off. A horizontal asymptote would level off. So it'd have to come to, it'd be like approaching some sort of horizontal line and get closer and closer and closer to it as you go, but never actually get there. So this is going up forever on this side, down forever on that side. That's not going to have a horizontal asymptote. That's not going to have a horizontal asymptote because that goes just up forever. As we go all the way over here, it's going up forever. As we go all over here, it's going up forever. There's only two possible spots for a horizontal asymptote. All the way to the right and all the way to the left. And it has to level off to be an asymptote. There could be one horizontal asymptote. You could get something that goes like that. So on the left, as I go to the left forever and ever, my y values will be going up and up and up and up, and it's not leveling off at all. But in this case, as I go to the right, it is leveling off, so there'd be a horizontal asymptote on this side of the graph, because these y values will start to get closer and closer and closer to zero, but it'll never actually get there. Notice that even though zero is a horizontal asymptote, I crossed through the axis twice. Horizontal asymptotes, all that matters, again, is what happens on the very, very right-hand side of the graph and the very, very left-hand side of the graph. In the middle, I can cross through as many times as I want. Something like this has one horizontal asymptote. So on the left-hand side, this will get closer and closer and closer to zero, but never actually get there. On the right-hand side, it just goes up forever, so that's not an asymptote. You could have two. And these are just a few examples. You could have tons of these. Actually, let me go back to the one. You could have one that's the same. So let's say I could have a horizontal asymptote there. And again, I cross through it in the middle, but on the left-hand side, it's going to get closer and closer to that forever. On the right-hand side, it's going to get closer and closer to that forever. Two horizontal asymptotes would be something like that, but they're different. So maybe this and this. So on the left, my horizontal asymptote's here. It's leveling off towards zero. As I go all the way to the left, I'm on the right. As I go all the way to the right, my horizontal asymptote, it's probably like -1, depending on how I label it, but it's going to level off in that direction. Again, you can cross through horizontal asymptotes in the middle. So you could get something like this. And it's an asymptote because as I go to the left forever, it gets closer to this. As I go to the right forever, it gets closer to this. I can cross through in the middle as many times as I want to. Alright, so how do we find those algebraically? So what you're looking for a horizontal asymptote is where the higher power is. That's kind of how some people like to remember it. Horizontal asymptote, higher power, start with an H, so when you're asked for one or the other. When you ask for horizontal asymptotes, you're thinking higher power. Okay, so there are three possibilities here. One is that the higher power, these are all going to be fractions. The higher power is on top of the fraction. That means we're going to positive infinity or going to negative infinity. So we're going up forever or we're going down forever, and there's no leveling off at all. and there is no horizontal asymptote. And I'll show you why in class. I think it'll be better if you do some of these problems first, and then we'll talk about why these rules exist in class after you've done some work. If the higher power is on the bottom, then there is a horizontal asymptote at y equals 0. So y equals 0 is a horizontal line. So if you tell me there's a horizontal asymptote at 0, it's actually not quite enough information. You want to tell me horizontal asymptote at y equals 0, because an asymptote is a line, and this way you're giving me the equation of a line. All right, the third possibility is that the highest powers are tied. In this case, there would be a horizontal asymptote at y equals, and then what you do is look at the coefficient on top divided by the coefficient on the bottom. Again, it's an equation, though, and that'll make more sense when I do an example. All right, but these are the 3 rules. I don't think these are too bad. You're just kind of following through there. You do have to simplify before comparing. And again, when I go through an example like that, I think that'll make more sense. All right, so if I start doing some problems here, let's say the limit as x approaches infinity of 4x to the third minus 8x over 6x squared plus 2x minus 7. Well, when we're dealing with infinity, the only thing that matters is the highest power. So if you imagine taking, like a billion and cubing it, well, now you're going to be at some huge number. Then you're going to multiply it by 4. And then you're going to subtract 8 billion, but you're still at a huge number. So as I get bigger and bigger, this part becomes completely irrelevant. Imagine I took 1,000 and squared it. Well, that's 1,000,000. Now it's 6 million, because I multiplied by 6. So adding 2,000 to that and then subtracting 7 doesn't really have any impact. So all you're ever concerned about is the term with the highest power in it. It doesn't have to be the first term, it just has to be the highest power. Then you compare the powers. That's a 3, that's a 2, the higher power is on top. So what we'd say here is the limit does not exist, and there are no horizontal asymptotes. And if I want to be more specific, we're going to positive infinity. We're going to positive infinity because if I think about plugging in a giant number, this would be a giant number to a giant positive number cubed is still a positive number. A giant positive number squared is still a positive number. So positive divided by positive gets us positive. All right, let's say, typically this is the only thing we're looking for, but just to describe to you what's going on there. Limit as x approaches infinity of 3x squared minus 6x minus 9 over 5x to the 5th plus 1. So again, this stuff does not matter. That's the highest power. That's the term with the highest power, and so is that. Then we compare the powers. 2 versus 5, the highest power is on the bottom. So you've got a limit of 0, a horizontal asymptote at y equals 0. It depends on the way the question asks. Do they ask for the limit, in which case you'd say 0, or do they ask for horizontal asymptotes, in which case you'd say y equals 0. And then the third kind is if they're tied. So let's say 3 minus 4x to the third plus 6x over 10x squared plus 8 minus 2x to the third. So we want the term with the highest power. None of the rest of it matters. You can kind of cross it out even or erase it if you want. Then compare the powers in those terms, so 3 and 3, so those are tied. And then what you do is look at the coefficients. So we're going to grab the negative 4 and the negative 2, and this would be negative 4 over negative 2, which comes out to 2. So that's your limit. And there's a horizontal asymptote at y equals 2. So again, it depends on the question. All right, so highest power on the top, limit does not exist. No horizontal asymptotes. Highest power on the bottom, limit is 0, horizontal asymptote at y equals 0. Limits, or the highest powers are tied. You look at the coefficients in front of them, grab those and divide them. That'll get you your asymptote. So let's look at a little bit trickier where I might give you a radical or something to simplify first. Limit as x approaches infinity of, let's say 3 minus x squared over 4 times 4 plus x to the third over 2x to the fifth minus 9. So if you look at it now, you can't compare the highest powers yet because this is not in its simplified form. So I'm going to say we need to simplify it, but we don't really need to simplify the whole thing. All I need to know about the top is what the highest power, where the highest power is, and what's the coefficient in front of it. So that has got to come from this multiplication. So if I multiply those two things together, I'm going to get negative x to the fifth. I could keep foiling, but the rest of the things that I foiled would not be the highest power, so I just don't care about them in this case. On the bottom, my highest power there is 2x to the fifth. And so none of the rest of it matters. This is basically what you're dealing with right there. Highest powers are tied, so you look at the coefficients. The coefficient on top is a negative 1. The coefficient on the bottom is a 2. So the answer would be negative a half, or horizontal asymptote at y equals negative a half. Let's say limit as x approaches infinity of 16x to the 16th minus 1 over 8x to the 8th. So, again, we have to simplify before we compare. So I need to get this basically out of the square root. And again, all I care about is the highest power. So I don't know how to take the square root of 16x to the 16th minus 1. But I do know how to take the square root of 16x to the 16th. And I don't care about the minus 1 because it's not going to be the highest power anyway. So I'm just going to take the square root of the highest term. Now be careful here. The square root of 16 is 4. Right? I don't think anyone's going to mess that up. I do think people would put 4 as a power. But that wouldn't be right. So when you're dealing with powers, remember there's really a 1/2 out here. So square root is like a 1/2 power. When you have a power to another power, which is what this is, you multiply those together. So this would actually be 4x to the 8th, not 4x to the 4th. You can kind of check that, because if it's a square root, you should be able to multiply it by itself and get back to this. And if I do 4x to the 8th times 4x to the 8th, then I would, if you're multiplying, you add the powers. So 8 plus 8 would give me 16, and that would work. So make sure you understand why that's an 8 there and not a 4. Bottom, I didn't do anything, so I'm just going to rewrite the 8x to the 8th. Highest powers are tied, so you look at the coefficients, and this would be a positive 1/2 or a horizontal asymptote at y equals 1/2. So just make sure you simplify before you compare. And remember, when you're square rooting powers, you're really just cutting them in half. And probably the trickiest kind is when x is negative infinity. They're not too bad. You just got to kind of reason through what would happen if I plugged in a giant number. Let's say 4x squared minus 5x over 4x plus 5. So we're going to simplify before we compare. We're only going to worry about simplifying the highest power. And if I square root 4x squared, that gives me 2x. But because it was inside of the square root, we've got to remember that this 2x is always positive. So you might want to put like an absolute value sign there to remind yourself of that, because I cannot get a negative number from this. On the bottom, I have 4x. I didn't do anything. I'm just kind of grabbing the highest term with the highest power and rewriting it. Now plug in, those are air quotes, plug in, negative 1 billion or something. And if I plug in negative 1 billion, the highest powers are tied. If I plugged in negative 1 billion, the top would be positive because it's absolute value, because it's coming from a square root. And the bottom would be negative. So you got to be careful here, because plugging in negative goofy makes your signs a little goofy. So that you're going to get 2/4 or a half if you want to reduce it, but it's going to be negative because plugging in a negative fitting on top makes it stay positive. Plugging in a negative fitting on the bottom makes it negative, and positive divided by negative is a negative. So horizontal asymptote at y equals negative 1/2 in that case. So hopefully that's enough to get you started, and rewatch it, pause it, practice your problems, whatever. I'm going to attach a worksheet with that, and we will go over any questions you have in class tomorrow.